This is the review for Chapter 9. We are starting on 574, which is the self-test, starting on number 1. So we have 2x squared equals 162. Very simple. Even though we have an x squared, we don't need to use the quadratic formula, which we do later in this chapter, because we don't have a separate x. So all we need to do is isolate that x squared, and then we can take the square root to get it down to an x. So first we do need to get rid of that 2. So I'm going to take 162 and divide it by 2, and that's 81. So x squared equals 81. And now that the x squared is isolated, I can go ahead and square root both sides of the equation, and that becomes an x. And then the answer here is both positive and negative 9. On to question number 5. V squared equals 16v minus 64. So now this problem, I can't isolate the v squared. I mean, it's already isolated. But I'd be taking the square root over here, and that's not the path that I really want to take. So what I'm going to do is I'm going to go ahead and move everything so that I can use the quadratic formula. And you could move the v squared over here, create a negative, or you can move these over here. And so that's what I'm going to do, just because we're not really used to a negative in front of the v squared, although it wouldn't be a big deal. So I'm going to minus 16v from both sides. So I'm going to get v squared minus 16v. Notice I didn't put them together because they are different. Equals negative 64. And if you wanted to, you could have done it on that step right there, but I'm going to add 64. And so now I have the 0 in here, so standard form. So v squared minus 16v plus 64 leaves me this. So from here now, I'm going to go ahead and identify that a equals 1, b equals negative 16, and c equals 64. All right, I can plug straight into my equation here. So the equation I'm talking about is negative b plus or minus square root b squared minus 4ac over 2a. So negative b, that becomes a positive 16 plus or minus inside here. So that's going to be negative 16 squared. Remember, that's always a positive number, so just be careful as you plug that in the calculator and you understand that's 256 minus 4 times a times c. So 256 minus 4 times 1 times 64. That gives me 0. So it's 16 plus or minus 0 over 2 times a, which is just 2. So whether I do plus or minus, we know when the discriminant is 0, I just have one possible answer. So really this is just 16 over 2. And my answer here is 8. Okay, number 6. So I have everything I need. A is 3, B is negative 9, and C equals 7. So plugging into my equation, it's negative B, so that becomes positive 9, plus or minus B squared. So negative 9 squared is 81, minus 4 times A times C over 2 times A, which is 2 times 3. So first thing I'm going to do is try and calculate my discriminant in there. So 81 minus 4 times 3 times 7 gets me a negative 3. So I can actually stop right there, but I'll show you what it looks like. I'm going to have the square root of negative 3, technically over 6. But we know as soon as the discriminant is negative, there are no solutions here. And the reason there's no solutions is because if I go ahead and try and take the square root of negative 3, it's going to give me an error. Okay, you cannot take the square root of a negative number. So as soon as we get to that issue, we know there's no solutions. Number 7, if the discriminant of a quadratic equation is 6, how many solutions does it have? So any positive discriminant always has two solutions. If they asked you to explain, you'd say because it's positive. Number 8, which of these graphs is equal to this? So first of all, it's positive, so I can go ahead and eliminate letter C. And so I'm looking at A and B. And I know if I plug in, say, 0 for X, that's going to make a 0 for Y. Both of those show 0, 0 as one of their points. So what you want to do is take these points that you can already see and just double check them. This one's saying that if you plugged in 2 for X, you'd get 2 for Y. So if I did 1.75 times 2 squared, I get 7. Okay, I don't get that. Now what about if I plugged in 1? It's telling me I should get something a little bit less than 2. So 1.75 times, and again, plugging it in right here, so 1 squared is 1.75. So that would make sense right there. And so letter A is the correct answer. The other way you could go about this is go to your y equals and plug in this equation, 1.75 x squared. And you could go ahead and you could look at the graph. But that might not tell you exactly what you need, but you could go to the table again and see when x is 2, I should have a really big number, 7. Whereas here, when x is 2, I get 2, or where x is 1, I get 1.75. That makes sense. Okay, so using your calculator is also another handy way to do that, to get that question answered. All right, we're going all the way over to number 16 on the next page. We're going to find the minimum of the parabola, so that is the bottom right there. And they want the minimum value of y, so that's going to be negative 1.6. 17, find the x-intercepts. So one of them is right here, x value of negative 3. But it also hits right here, and it looks like it hits right on that value, so here's 0, that would be 1. So the two x-intercepts are negative 3 and 1. Now, if you gave the points, that's fine, negative 3, 0, and 1, 0. They're just looking for the actual x-intercepts, the value of x when it hits the x-axis, negative 3 and 1. And then find the equation for the axis of symmetry. So axis of symmetry goes straight up and down through the middle of this. X value never changes. The x value is always negative 1, as you can see right there. And so my axis of symmetry equation is x equals negative 1. 21, true or false, this parabola opens down. So you see a lot of negatives, so you might think it does, but all we have to do is look at the coefficient of x squared. Okay, and that's a positive 1/2. Doesn't matter that it's a fraction, it's positive. This will open up. So this is false. And if they ask you to explain yourself, you would say the coefficient of x squared is positive. It opens up. On to 23. We're going to use the discriminant to give the number of solutions. So I'm going to copy this down real quick. It's already in standard form, so I can pull my a, b, and c. A is negative 3, b is 12, and c is negative 7. So we're plugging in for the discriminant, b squared minus 4ac. 12 squared is 144 minus 4 times negative 3 times negative 7. Let's go ahead and plug that all the way in. 144 minus 4 times negative 3 times negative 7. I get 60. So it says use the discriminant, not just give the discriminant. Use the discriminant to determine how many solutions there are. So since it's positive, there are 2 solutions. Any positive discriminant means there's 2 solutions. So the answer to 23 is 2 solutions. In 24, not in standard form. So first thing I need to do is add this 4, get it over here so that I have a 0 and I'm in standard form. Doesn't combine with anything. The plus 4 is just going to stay here on the end. And so A equals 1, B is negative 4, and C is positive 4. So when I plug into the discriminant, b squared, if you want, you can put in, instead of actually getting the answer, you can just write it out as negative 4 squared. Notice that I put it in parentheses. If you're going to plug it in your calculator, you need parentheses around a negative when you square it. 4 times 1 times 4. So if I went ahead and plugged all of this in, so I already know that this is 16, positive 16. But if you're going to punch it in, which I know a lot of you like to do, you would do it just like that. Got to have the parentheses. Minus 4 times 1 times 4. You get 0. And anytime you get 0, there is one solution. So again, if you typed it in without the parentheses, negative 4 squared minus 4 times 1 times 4, you get a totally different answer of negative 32, and you would tell me that there are no solutions, and you would obviously be wrong. And the reason it is because negative 4 squared, when you type it in like that, it tells you it's negative 16. But negative 4 squared is positive 16. Negative 4 times negative 4, which is what negative 4 squared is 16. Because anything squared is times itself, and negative times a negative is a positive. So you got to be careful there. All right, so that's the end of the self-test. Moving on to the chapter review on page 576. All right, on to the chapter review on page 576. A little more of the same, but differences. So number 1, similar to the first one we did on the other page, we don't need to use the quadratic formula here because we only have an x squared, we don't have an x. So we're just going to divide by 4 to clear that out, leaving us x squared equals something, and then we'll take the square root from there. So 676 divided by 4, 169, and we will square root that to get just x by itself, and I know that's 13. And it's also negative 13, so positive and negative 13. Number 5, we haven't looked at these in a while. So we have this whole binomial being squared, this whole quantity being squared. And so we can square root to get rid of that. We don't need to expand it out. But first we want to get rid of this 2. So we're going to divide by 2. That goes away. And now the reason I can do that is because it's being multiplied. And so I still have m plus 3 squared. That's going to equal 36. I'm going to square root now to get rid of this squared. And I have just m plus 3. The square root of 36 is both 6, but it's also negative 6. So I do need to be careful and make sure that I don't forget to do both of them. So I'm going to minus 3 here. M equals 3. I'm going to minus 3 here. And m equals negative 9. So both of those are possible answers, 3 and negative 9. Okay, number 9. Now we're solving with the quadratic formula because we have a squared and just a regular variable. So this is in standard form. A is 1, B is 7, C is 12. So plugging in, it's negative B, so negative 7 plus or minus B squared, which is 49, minus 4 times A times C, over 2 times A, which is just 2. All right, so underneath there, 49 minus 4 times 1 4 times 1 times 12 is 1. So in here I get 1, and the square root of 1 is just 1. So I'm going to have negative 7 plus or minus 1 over 2. Split that 2 ways. I have negative 7 plus 1 over 2, and I have negative 7 minus 1 over 2. So when I add 1 to negative 7, I get negative 6. And so that's going to be negative 3. And then here I get negative 8 over 2. And so that equals negative 4. So those are my 2 possible answers, negative 3 and negative 4. Next up, number 10. Okay, we need everything on the same side. Now we're kind of used to clearing out the right side, but it doesn't matter. So since there's already two things over there, rather than doing twice the work, I'm just going to go ahead and minus this one. And that will isolate everything. So 0 equals x squared minus 14x plus 49. Notice I didn't try and combine anything. This has an x. These are different. They stay separate. And now that I have this 0 over here, I have my a, my b, and my c. So a is 1, b is negative 14, and c is 49. Okay, so plugging into my equation, negative b, so that's positive 14, plus or minus, you're going to square 14, that's 196, minus 4 times a times c. So 196 minus 4 times 1 times 49 is 0. Okay, so this becomes 0. Square root of 0 is 0, so it's 14 plus or minus 0 over 2 times a, so just 2. Well, the 0 goes away. There's only one solution. It's 14 over 2, which is 7. Okay, number 15. So we're not in standard form. I'm going to minus the 2 to make a 0 on that side. Nothing combines. They just all stand separate. So it's a minus 2. So a is 5, b is 9, and c is negative 2. So negative b would be negative 9. Plus or minus square root. B squared, 9 squared is 81. Minus 4 times 5 times negative 2. All that's over 2 times a, so 2 times 5 is 10. So starting inside my radical, which is my discriminant, 81 minus 4 times 5 times negative 2. Gets me 121. So it's negative 9 plus or minus square root of 121 over 10. Now, square root of 121 is a nice number. It's 11. So this is negative 9 plus or minus 11 over 10. And so we'll split that two ways to get our two answers. Negative 9 plus 11 over 10, negative 9 minus 11 over 10. So we get 2 over 10. When we divide that, that's 0.2. Perfectly fine. Here we get negative 20 over 10, and so that's negative 2. So my two answers are 0.2 and negative 2. All right, after 15, we go to 16. Not in standard form yet. So we have to add 8 to get rid of it. And so A is 2, B is negative 8, and C is positive 8. So negative B, negative 8, that's positive 8. B squared would be 64, minus 4 times 2 times positive 8. And then on the bottom, 2 times A, 2 times 2 is 4. So 64 minus 4 times 2 times 8 is 0. So I end up with the 8 plus or minus 0 over 4, which just drops off. It's just 8 over 4, one solution of 2. All right, done with that section. On to number 21. Now just looking at the discriminant. So first we're going to just calculate the discriminant a couple times, and then we're going to use it to talk about how many solutions there are. So 21. My A is 1, my B is 4, my C is negative 8. Discriminant, all I need is B squared minus 4AC. So B squared is 16 minus 4 times 1 times negative 8. I get 48. And for 21, they're just asking you to calculate the discriminant. And so that is the discriminant. It's 48. 22. Can't leave this over here minus the 1 to bring it on this side. So now it all equals 0. So A is 7. B, it says minus y, that's negative 1. And C is negative 1. So B squared minus 4AC. It's negative 1 squared. If you're going to plug that in your calculator, make sure you put it in parentheses like this. 4 times 7 times negative 1. And the discriminant is 29. So there'd be 2 solutions here and 2 solutions here because we got positive discriminants. All right, skipping to 24. Find the number of solutions here by using the discriminant. So we're going to do the same thing, and then we're going to say how many solutions there are. This one's in standard form, so that's nice. A is 1, B is negative 3, and C is negative 8. So plugging into the discriminant, you're going to get negative 3 squared, which is positive 9, times all that. So negative 3 squared minus 4 times 1 times negative 8. We get 41. And so now from there we can say there are 2 solutions because the discriminant is positive. $25. So I would subtract the 3v if I was doing this, because instead of trying to get those to the other side, let's just move one thing. So minus 3v on this side. So 0 equals 2v squared minus 3v plus 4. It's just convenient to put them in that order. You technically don't have to. But a equals 2, and b equals negative 3, and c equals 4. So plugging in, it's negative 3 squared minus 4 times 2 times 4. Negative 23. And when you get a negative discriminant, there are no solutions. And it says how many solutions. So if you put 0, that would be fine as well. So the discriminant wasn't 0, but there are 0 solutions because the discriminant was negative. 26. Again, I only have one thing to move, so I'm going to go ahead and move that. So 0 equals negative m squared plus 6m minus 9. A is negative 1. B is 6, and C is negative 9. So 6 squared minus 4 times negative 1 times negative 9. We get 0. So be careful, the answer here is not 0 because they're asking you to use this answer to tell how many answers there are. When the discriminant is 0, there is one solution. All right, and 27. Kind of threw a tricky one in there for you. So you would have to distribute here to get started. W times W is W squared. W times this is negative 2W, and that equals negative 8. And then we'd have to add 8 to get this in standard form. And so now A is 1, B is -2, and C is 8. So -2 squared minus 4 times 1 times 8. And I get -28. The discriminant is negative, so the answer here is 0 or no solutions. How many answers are there? How many solutions are there? There's 0. There are no solutions. All right, and then the very last one that we need to do here on the next page is 31, looking at the graph, just letters A and B. So 31A. So first of all, this graph that we see here is from this equation, shows the height of a ball in meters after it is thrown from the ground. Initial upward velocity of 20, we see that right there in the equation, and it's -4.9 because it's in meters. But we're just pulling this from the graph now. So give the height of the ball after 1 second. A couple options. You could go back and plug it in, or you can just look here on the graph. 1 second, follow it up. The height of the ball is 15. That's what you would say, right? Now, if it said use the graph, I think that's reasonable. But let's go ahead and actually plug this in. They want to know 1 second. So 1 squared plus 20 times 1. I'm going directly into this equation. And the actual answer is 15.1. Now, you're not going to see a 15.1 on the graph when it's counting by fives, right? So this is a good example of when is it better to use the graph, when is it better to use an equation. The equation will always give you the exact answer. The graph sometimes will, but in this case it doesn't, even though it sure does look like it's right on that corner. So a good example to not always trust a graph. If you've got the equation, use it. So it's not 15, it's actually 15.1. Letter B. Find when the ball will reach a height of 15 meters. Okay, so 15 meters. Well, you go ahead and you take a look. It looks like it's about 1 second. And the next time, it looks like it's a little bit after 3, so maybe 3.1, something like that, if you were just guessing, so based on the graph. So what we want to do now is actually use this equation here and see if we can figure it out. So we want to know, when does it equal 15? So h is 15, and it equals -4.9 t squared plus 20 times t. So we can estimate using the graph, and that's fine. Okay, but we can also get the exact answer using this. And so we're going to use the quadratic formula. We don't want the 15 here, though. We need it on the other side. So this is in standard form. So A is -4.9, B is 20, and C is -15. So quadratic formula, -b, so -20, plus or minus square root b squared, so 20 squared, if you just want to write that and plug in the calculator, that's fine too, be 400, minus 4 times a, which is -4.9, times c, which is -15, all under the square root, over 2 times a, which is 2 times -4.9. Looking a little complicated, right? Now we know what they should come up close to. So if we do something wrong and we don't get a number close to 1 or close to 3.1, we know something's off. So let's run this through and see what we get. So 20 squared minus 4 times -4.9 times -15. Get this really big number. So let's take the square root of that. And we're going to kind of have to round this one off here, huh? For now, let's leave a lot of decimals here. All divided by 2 times negative 4.9. So we got to do this once with a plus and once with a minus. So negative 20 plus 2019.927226 divided by negative 9.8. And obviously here something's wrong, right? Clearly. So we need to go back here and figure out what are we missing. So going back real quick, I just started scanning through my calculator and I'm like, I'm looking at this and everything looks to be just fine. And then boom, I just plugged in something goofy in my calculator. Instead of 20 squared, I put in 20 squared. So let's start over here. 20 squared minus 4 times 4.9 times, and I almost messed up again. 20 squared minus 4 times negative 4.9 times negative 15. It's 106. So instead of this big goofy number, I just leave that right there? It is 106. So we're going to take the square root of 106. And so it's going to be negative 20 plus or minus 10.2956. That's good enough. Over negative, and we said 2 times negative 4.9 was negative. Nope, I did that wrong again. 2 times negative 4.9. There we go, negative 9.8. So I'm making this look harder than it is. So we'll split that 2 ways with the plus and the minus. So negative 20 plus 10.2956 divided by negative 9.8. And you can see that is one of the answers here, 0.9902. Okay, we'll leave it just like that. So that would be this one. That looks like it's just about at 1. It's actually just before. It's 0.99. So by the graph, we would say about 1. To be a little more exact, it's 0.9902, and it's even more exact if you keep all those answers. And then let's also do minus. So negative 20 minus 10.2956 divided by negative 9.8. And remember we said just about 3 or 3.1, so 3.0913, which is about the same as 3.1. So for a graph question, now if you're talking quiz or test, you're not going to have to go this far, but it is good to look into these numbers a little deeper and understand how the graph is approximate. And if we want to be more exact, we're going to plug directly into that equation. So if you just looked at the graph and you said about 1, about 3.1, 3.2, perfectly fine.